degrees of freedom calculation is different in this type of problem. The first thing we need to do, just like goodness of fit, any chi-squared, is to make sure that all the expected values are greater than or equal to 5. They are, so we can continue without combining. And now we're ready to do our degrees of freedom. If we had to combine, the degrees of freedom would change. So degrees of freedom for continuity table test will be the number of rows of observed data minus 1 times the number of columns of observed data minus 1. Alright, this is the very simplest table. It's got 2 rows of observed data and 2 columns of observed data. So we have 1 degree of freedom, smallest possible chi-squared goodness of fit table. Alright, so now we can draw our distribution. Alright, chi-squared with 1. Alright, so we'll represent this with a chi-squared of 1, alpha of 5%. So now we can go to our chi-square tables, look up the critical value, 1 degree of freedom, 5% alpha, so 3.84 is the critical value. Okay, so anything less than that, the null is possible. There's an insignificant relationship between our 2 variables. Where the alpha is, we'll reject the null and we'll talk about a significant relationship. Okay, so let's now do our decision rule. Alright, first part, for the acceptance region, the calculated value of chi-squared is less than or equal to the critical value of 3.84. Do not reject the null. And we'll interpret that normally as follows. There is an insignificant relationship between our 2 variables, and specify your 2 variables, political preference and region. Alternatively, calculated value of chi-squared is in the rejection region, greater than 3.84. There's too much difference between the observed and expected to be just normal sampling error, and there'd be no relationship, so we'll reject the null and accept the alternate that there is a relationship, and there's a certain probability of error in making such a statement. There is a significant relationship between our 2 variables, political preference and region. Alright, we're now ready to do our calculated value of chi-squared. Let's go back to our table and look at the numbers. Alright, our formula for the calculated value of chi-squared is the same as for the goodness of fit. That's the summation of the expression observed minus expected squared divided by the expected. So we do that for each cell. Alright, so the first cell, 40 minus the expected of 30 squared divided by 30. Okay, even though we do them all there's no need to write them all down. And I'll go plus dot 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 down to the end, in which case we'll have 70 minus 60 squared divided by 60. Alright, and then it's a matter of calculating all those numbers. Alright, and that boils down to 11.1 recurring. And clearly that's greater than our critical value. Alright, looking at a distribution, 3.84 is the critical value. Our calculated value is way out there in the tail, so we're going to reject the null. So decision. Since calculated value of chi-squared is 11.11, which is clearly greater than the 3.84 for the critical value, we'll reject the null as being very unlikely and accept the alternate, then of course as being very likely. And you can say there is a very significant relationship between our two variables, political preference and region. And that's the end of the test. All tests that we'll do for chi-squared continuity table, well, nearly all of them, can be done in that format. Right? Some of them you may want to do different in the long run in terms of wording, but the process of calculations is all the same.